Okay, what I wanted to cover today was a quick primer on all of the steps that you need to go through to take a brand new PIC16F88, okay, which is this chip right here, all the way to the point where if you apply power to it, it'll cause this LED here to blink. You'll notice by looking at the breadboard that we have its current limiting resistor, but it's pulling off of this pin off of the PIC here. Okay? Now, we won't concentrate on the electricals of it, but PIC16 chips are so nice that really the only external discrete other than power that you need to run it is this 20-cent crystal here. It's a 20 megahertz crystal. These PIC16F88s run at 20 megahertz, which is a bit better than the 4 megahertz that they used to work at. But what I wanted to show you today was how you actually program one of these things. I have my programmer in the other room, so what I'm going to do is I'm going to take the chip, and what you do is you take an anti-stat bag, and you have to do this every time you move around, okay, because it's very easy to blow PIC chips, okay. So what we do is we take the chip off the board, okay, which I'll do carefully. And I'll put it in the anti-stat bag. Usually I have my board, my breadboard right next to my programmer, but unfortunately I have to go into the other room. So it was good to cover ESD procedures. Where is it? There it is. Okay, here's the anti-stat bag. Whenever I touch it, it translates to the pins, and anti-stat bags have a high resistance, so it slowly goes into the chip. Okay? What we're going to do is, this is the MP Lab IDE. Now, they're horribly complicated these days, but one thing that you have to remember about PIC16s is that they're I don't want to use the wrong terminology here, but they're very linear, okay? That you can see the opcodes here. Each one of these opcodes translates directly. They call it a compiler, but it's actually an assembler, okay? And assemblers are very linear. Each one of these commands here, like NOP, they just swap out that NOP and put in the byte that corresponds to that particular command. It's the same thing with GoTo. GoTo has an actual machine language code. Okay, you got to remember that with PICs is that they're very, very 20th century. Okay, they don't multitask. They do have interrupts, but they're not like, let's say, the Beagle boards or the Raspberry Pis, okay? The good thing about that is that because they're so linear, they're really easy to understand, okay? We're not going to go into exactly what this program means, but this is what it is. And all it does is run a loop with a short delay here that applies power to one of its pins, and if you hook up an LED, you can turn it into an LED blinker. It's just something I got off the internet. What we can do is we can build it. We go under Run, Build Main Project. I threw the source code into a file called ledadc1.asm, and you just put it under your source files. You just make a new project under the MP Lab IDE, and that's all you do is you just cut and paste the code. Okay. what I like to do is I like to cut and paste a template so that when I code, I don't have to worry about things like this here. There's various flags that you have to set internally. I just include the PIC16 whatever .inc, and I use a template just to set these flags, because I've found that I hardly ever have to change them anyway. And you just program this portion here. Okay, now I'm pretty sure it's built. Yeah, build successful. Now whenever you build an MP lab for a PIC16 series, it always comes out as a single file called a hex file, and that hex file contains the hexadecimal, or rather the machine code, that you burn directly to the PIC. This is our programmer. It's a bootleg K150 that I got out of Hong Kong on eBay for $10. Okay, as you can see, it even comes with the ZIF socket, and it's connected via USB around to my PC. Now it's been pre-configured. To configure it, you need to download two programs. One is the prolific USB to serial device driver, which allows basically a bridge between your PC and the programmer, such that you can talk serial over USB, which is the cable that we use to connect it. Okay, so we take our PIC chip, and here it is, and we've used correct ESD procedures. And what you do is you go to the microburn program. See if I can find it. Here it is. Okay, this is what the microburn program looks like every time. You'll notice that it has some twitchiness to it. That's normal for a K150. Okay, the important thing to set is the particular chip that you're using right here, and it's set correctly, PIC16F88. You'll notice that there's a bunch of different types of PIC chip, and you can select them all from here. Okay, but we have the correct chip type in there. Also, what's important is this diagram here that shows you where the chip has to be placed on the ZIF socket. Okay, so instead of putting it right at the top of the ZIF socket, you'll notice that we have to put it one down. Okay, see how it's not there? It's there. Okay, a lot of times I'll put a little piece of foam board or something in the ZIF socket to cover these holes so that I don't misalign it. Okay, now we just built the hex file, so we go to load like this. Okay, and there's our hex file. Sometimes you have to kind of go digging for it. I believe, let me see if I can find it, because it actually did take me a little time to find. It's under NP Lab, the project name under dist. Okay, and that stands for distribution. You drill down default production, and then your resulting hex file, and it's only one file, and it's just the program we just built. Okay, and you load it. You'll notice the hexadecimal here change. Okay, that's how you know that it's loaded. Okay, so what we do is we take our PIC chip, okay, and we insert it. How you can tell the orientation on the PIC chip is that all chips have a little divot at the very top of it. Okay, that tells you the chip's orientation. Okay, all ZIF sockets have a little lever. You plug it down in order to clamp the chip in ready for programming. Okay, so there's the chip in the programmer. Here is an erroneous printer screen that we will get rid of, and we hit program. There it is again. And then we hit yes. And it really is that quick. Programming is complete. Click OK, and make sure you verify after programming it. Okay, program, verify, and it's verifying that the program is identical to the hex file in the microburn program. Okay, and that's all it takes to program a PIC chip. Is just that. Okay, so we go down to the programmer, we lift the ZIF lever, and of course we put it in the anti-stat bag to take it back to our breadboard. Okay, I managed to find the pause button on my video camera, so I'll save you the few seconds for walking over here. What I've done is I've taken the PIC chip that is now programmed. Okay, if you put in a brand new chip into this circuit here, it won't do anything. This LED will not turn on. Okay, now we've loaded that blink program that we built and programmed onto the chip. This is the crystal that's necessary to run it as far as timing goes. But other than this crystal, no other discrete component is necessary for it to run except for power. Okay, so what we do is we power it on like this, and the power comes through this lead here, horizontally across, and ground comes on this side. Okay, we have the crystal hooked up, and what we do is we pull off of this pin here through a resistor to the LED. Now if it was a brand new chip with no program on it, this LED would not be blinking. Okay, since we programmed it, since we burned it, it has the ability to blink an LED through that particular pin. Thank you for watching. It was a pleasure.